find limits here. Analytically. Analytically means using algebra. We don't have to look at the graphs. All right, so the limit of a polynomial and rational function. So the limit as x goes to c of a polynomial function p of x. Who knows what polynomial function is? No. Okay, so a couple things I heard: many parts, many terms, and something like x squared plus x minus something. X squared plus x minus 2. Polynomial. What specific type of polynomial is that? It's a trinomial, a quadratic function. Polynomial means many terms. Okay, it's something that you could be like x to the 4th minus 5x plus 6x squared plus 2. Okay, the limit as x goes to c of some polynomial is this. Watch this. See if you can figure out what we do to find the limit of a polynomial. Is p of c. What are you doing? Tell me what you did. Plug c in for x. Now tell me what c is. It's an x value. It's a number. All right? Rational function. What's a rational function? A rational function is a fraction. You have a p of x and a q of x. Okay? What is the limit as x goes to c of a rational function? It's p of c divided by, or q of c. So what did you do there to find the limit of that? Same thing, you put c in for x. So here's an example. I want you to find the limit as x goes to 1 of x cubed minus 3x plus 6 over x plus 4. How would you find that limit? Put 1 in for x. And you get 1 minus 3 plus 6, 4 over 5. So the limit as x goes to 1 of that function, the y value is approaching 4/5. What's another word for what we're doing? Substitution. All right, the limit of a function with the radical says that the limit as x goes to c of the nth root of x is, can you guess? The nth root of c. Substitution. Plug the x value into the function. Theorem 1.5. The limit of a composite function. Composite function is the combination one function put into the other. So let's say I know I'm given that the limit as x goes to c of g of x equals L. I know that. So then the limit as x goes to c of the composite function f of g of x, where g of x is the inner function of some other f of function, that is equal to f of the limit as x goes to c of g of x, which would then be as simple as f of, what was this value equal to? L. All right, now I'm not going to write down all of the trig theorems. Theorem 1.6, I'm just going to write down one of them. Trig limits. You can write them all down if you want to. But let's say 1 is the limit as x goes to c of the sine of x. What does it say that that limit is equal to? It's in your book. Okay. Sine of c. So what did you do? Plug c in for x, and then do you know how to find the sine of something? How? Unit circle. Don't have a unit circle? Get one. Calculator's fine, but what if you are like in the next rule? Oh, not number 2. Let's go all the way down to number 5. Say I want to find the limit as x goes to c of secant of x. What do? Secant of what? C. So let's say I wanted to find the limit as x goes to pi over 4 of the secant of x. How would I do that? It would be the secant of pi over 4. Do you know how to find the secant of pi over 4? Panic. Oh, my calculator doesn't have a secant button. Secant is the reciprocal of cosine. So if I find the cosine of pi over 4 and take the reciprocal, that's what 1 over the cosine of pi over 4 means. It means reciprocal. If I find the cosine of pi over 4 and flip it, then I'll have the secant of pi over 4, won't I? What's the cosine of pi over 4? As a radical, decimals won't get you any points here. Radical 2 over 2. What's the reciprocal of radical 2 over 2? How about it's just radical 2? Because 2 divided by radical 2, multiply top and bottom by radical 2, you get 2 radical 2 over 2, which is radical 2. So the secant of pi over 4 is radical 2. Should you be able to do that stuff? Yes, you should. Yes, you should. All right, we're not done. Because the problems get a little bit harder. But first I want you to try a problem, 2 of them, and then compare with your... So let's say I wanted to find the limit as x goes to 3 of g of x. Could I do that?
Yeah.
Okay, how? Plug 3 into x. And what would I get on top?
24.
24 divided by, and that would equal, okay, so that's easy. So what if I wanted to find the limit as x goes to 1 of g of x? How would I do that?
Plug 1 in.
Plug 1 in. And no, what do you get on top? Listen, this is so important.
0 over 0.
0 over 0, which is not undefined. It is not, does not exist. It is, it has a very special name in calculus. Okay, 0 over 0 is called indeterminate form. It is very important that you know that it's called indeterminate form, and it's very important that you know what indeterminate form means. Indeterminate form is 0 over 0. There's other indeterminate forms like negative 1 over 0, or 57 over 0, or infinity over infinity. It's indeterminate because you can't pinpoint a single numerical value for that answer. Okay? Which is what we're looking for in a limit. Okay? And we can't just jump ahead and say does not exist. Especially when we get the indeterminate form of 0 over 0. Because 0 over 0 means, hey, you probably can find a limit. Probably this function that you started with up here is actually a simpler function. You could actually take this function and make it easier on the eyes by doing some algebra. And then if you tried the substitution again, it would probably work out. So indeterminate form means, hey, do some algebra and try substitution again. So we're going to go back up and we're going to look at this function, and the technique I'm using here is called write a simpler function, or simplify the function. Okay, now it's not always simplify the function, because some of the simplify methods we're going to learn to use on Thursday are going to be a little weird. Okay, but this is a pretty normal simplify problem. So simplify the function. So how might I go about simplifying that? Factor an x out of the top. Okay, now factoring doesn't make this simpler at all because it's still just as bad. I still can't put 1 in. I'm not done factoring. How else can this factor?
You can go into x plus 1, x minus 1.
Good, that's the difference of squares. And then notice the x minus 1 cancels. So what is g of x? What's a simpler way of writing that original function? X squared plus x, or x times x plus 1. Either one. Is that the same thing? Is that the same as that function actually?
Yeah.
Okay. So now that I have a function that's nicer, easier on the eyes, let's try finding the limit as x goes to 1 of this function. X squared plus x. What are you going to get for your limit now?
2.
You're now going to get 2. Okay? The graph of this function, actually looks something like this. That's what the graph, this is the graph of that function right there. What is the limit as x goes to 1? Where y value are the lines approaching? 2. But is it actually defined there? No, because it has an open circle. Okay, now did you have to graph that to work this all out? No, you didn't. You need to know that when you get 0 over 0, it means do some algebra and then try substitution again. So you'll run into that in the very last few problems in your homework. So you are going to have some time here, at least a half an hour, right, to work on this. I had people in last period get the entire assignment done. Now, one little note, you don't need to do 20 through 26 on separate paper. Just do it all on one paper and turn it in.